Hello guys, welcome back. In the previous video, we have understood how to find sum of digits of a number in a single while loop with just one if condition. Now let's try to optimize this logic further from order of n to order of 1. So how shall we do that? Let's see that. So if I just take all the digits, so how many digits do we have? 0 to 9. So when do we get the output to be 0? So we get the output to be 0 when our number is 0. So I can just simply write, if my number is 0, we would simply print the output to be 0. Done. So now if I just take the number 9, so let's try to understand there is some beauty for this respect to value 9. So what is that? If I just take all the multiples of 9, so what are the multiples of 9? So 9, 18, 27, so on. So let's take some random multiples of 9. So I've considered here 9, 18, 27, 36, 99, 108, 999. So just try to add all these digits. So for 9, sum is 9. For 18, it's 9. For 27, 2 plus 7, 9. 63, 6 plus 3, 9. 99, you are getting 9 plus 9 to be 18. 1 plus 8 to be equal to 9. So again 108, if I take 1 plus 0 plus 8, which is 9. Again triple nine, 9 plus 9 plus 9. You are getting the answer to be 27. Again 2 plus 7, the answer is 9. So that's the beauty of the value 9. So now what can I say here if I want to get the answer to be 9? It should be definitely a multiple of 9. If it is a multiple of 9, simply we can print the output to be 9. So now what are the digits which are left over? The digits which are left over are 1 to 8. So here, if I want to get the 8 as the highest reminder, so what I'm trying to do over here, if I want to get 8 has the highest reminder, with what number we are supposed to divide? So we'll be dividing with the value 9. So this logic, I have explained it in my arithmetic operators video. I'm trying to add that video on the top right corner. If you haven't watched that, so I suggest you to go back, watch that video and come back to the explanation over here. So if I want to get the highest reminder to be 8, I'll be dividing with the value 9. So let's take the example 892 only. So here if you observe 892 is equal to 0. No, the first case is gone. So in the second case, in the third case, we are trying to do, of course, all the time modulus 9. So here modulus 9 came into picture. Here also modulus 9 came into picture. So let's try to divide this 892 with 9. So 9 how many times? So 9 nines are 81. So you get the remainder to be 8. So let's take the value 2. So again 9 nines are 81. So we get the remainder to be 1. So if you observe here, is the remainder 0? If the remainder is 0, the answer is 9. So the remainder is not 0. So what we are supposed to print? Number modulus 9, which is our remainder. So now our remainder is the value 1. So this is how the logic works, guys. Now there is no scope of having while loop at all. Now let's try to write this code in our Visual Studio. So let me try to comment this code. So going over here, so just simply write if our number is 0, so we would print the value to be 0. So I'll go for elif. If our number is multiple of 9, so we would print the value to be 9. If that's not the case, we would simply go for printing the value of number modulus 9. So I'll just simplify it to short. So instead of having one more condition, I'll just combine these two into one. So I'll write over here. So if number greater than 0 and number modulus 9. So if I just go for simple 0 modulus 9, the answer should not be 9. The answer should be 0. That's the reason I'm writing number greater than 0 and multiple of 9. I'm just going for the value 9. If not, I'm going for this case. So even though if I take the number to be 0, so 0 modulus 9, you're getting the answer to be 0 only. So let's try to run this code and check. So over here, so maybe we can just take this large value. All right. So getting the answer to be 3. So I'll just run once more. So we're giving the value 892. So instead 892, let's shuffle the digits. So even though you shuffle the digits, still the sum is same. So 829. Still answer is 1. So this is how it works, guys. Let's try to see what is the time complexity for this program. So time complexity would be order of 1 because there is no while loop at all. So that's the reason we can say this is very optimized. So if I want to still further optimize this step a bit more, so let me just take one scenario. So I would say here the multiples of 9 are 9, 18, 27, 36, so on. So if I do modulus 9, I am getting the answer to be 0. So what if I take the same multiples, I will decrease all these numbers by 1. So if you decrease all these numbers by 1, what I'm getting 8, then you get 17, 26 and 35. So like what is the purpose? I'm trying to decrement it. So if for all these numbers 9, 18, 27, 36, the answer should be 9. But if I do modulus 9, I'm getting the answer to be 0. So what I'm trying to do is I'll try to take all these numbers so which were subtracted by 1. Now I'll try to do modulus 9. So if I try to do modulus 9, just check what do you get. So 8 modulus 9, the answer would be 8. Similarly, 17 modulus 9, the answer is 8. 26 modulus 9, the answer is 8. Similarly, 35 modulus 9, the answer is 8. So now we are getting the answer to be 8. But what we are supposed to get, we need to get the answer to be 9. So after I do subtracted by 1, modulus 9, I'll do plus 1 to all of these so that the answer would be 9. So now what I'll try to do over here is I'll just simply take print number minus 1, so which is modulus 9 plus 1. So this single line logic would give us the sum of digits until sum is single digit. So let me try to run this code. So let's give the value. So 298. So just I'm reordering the digits. So getting the answer to be 1 and 1. So maybe if I just go for so this large number, so getting the answer to be 3. That's how it works, guys. So now still the time complexity for this would be order of 1 only. And even here, there is no if condition, no else condition. So but this logic would fail for number to be 0. That too, it only fails in Python. So if I give the number to be 0, so we are getting the answer for the last one to be 9. So it won't work in Python, but this works in C, Java, C++. So, but negative numbers, you get the modulus 9 different in Python. That's all for this video, guys. Thanks for watching. See you guys in the next one.